about the diversion works, diversion headworks, and few classes we have taken to concentrate on the causes of failures of weirs and barrages on the permeable foundation, along with the types of diversion headworks and components and function of each component we have seen. Then creep theories also we started discussing. Bly's theory we discussed and we worked on one problem. Lane's weighted theory also we have seen. Then Khosla's theory we discussed in the last class. So today I'd like to just concentrate on the application and working out a problem on Khosla's theory, so that it would be a continuation of what we have discussed on the Khosla's theory for determining the uplift pressure and what are the various correction factors to be applied, and calculation of the exit gradient also. Okay, so one problem is the problem under the application of the Khosla's equation. There are two things: the uplift pressures at a different junction points on a permeable foundation, on a floor of a permeable foundation, can be calculated either with the help of the Khosla's equations or Khosla's curves. So we see both. So this problem pertains to the determination of the uplift pressure at the key points and also the exit gradient for the weir section which is shown. Also find whether the section provided is safe against the uplift and piping if it is founded on fine sand with permissible exit gradient of 1/6. Use the formulae involved. So we try to make use of the formulae for solving this problem, not the curves. The section given is like this. Okay, a weir at a level of at a funnel of 108.5, and the floor, the bottom would be, the crest level is 108.5 and the bottom is 107.0. So you have the upstream slope as well as the downstream slope for this foundation, for this floor, and this floor is resting on a permeable foundation. You have on the piles at this point, say pile 1, and you have the intermediate pile here, pile 2, and then this is pile 3 end piles. Okay, pile at the beginning, intermediate pile as well as the end pile are there. Other things that are given are, like you can identify the thickness of this floor and the pile. The starting pile is at a distance of 0.5 meters from the face of the floor. Similarly, the end pile also is at a distance of 0.5 meters from the end of the floor. The intermediate pile is located at a distance of 16.5 from the edge, and the bottom of this sheet pile is at RL of 97.00, whereas on the end sheet pile the cutoff is at a RL of 95.0. 97.0, 95.0 are the bottom levels. Similarly, the intermediate pile is located at a bottom level of 97.0. And what else? All other things are like the distance between one pile to the other pile, and all these locations are given. The floor thickness, if you see, 103.5 is the top of the floor. The bottom of the floor is 102.0. So the thickness of the floor is 1.5 meters here. Whereas here, the thickness of the floor is written more, 101.5. So 103.5 minus 101.5 is the thickness of the floor here. Okay. So all other things are given. We see from first pile to the end, it is 53.5. Or from end to end, it is 53.5 plus 0.5 here. This 0.5 also is to be added. Okay, so what we need to do? We need to calculate the uplift pressures, percentage pressures, by making use of the Khosla's formulae. Use the formulae involved. So we make use of the Khosla's formulae for calculating the uplift pressure at the junction points. Also, the exit gradient will be calculated. Okay, so if you see the junction points, so for an end pile, in a simple line diagram, you can see this is the end pile CD. the cutoff end pile. E, C, D is the inner junction point, C is the outer, and D is the bottom of the pile line. Okay, H is the head causing flow, and B is the total horizontal width of the floor. Okay, so pile line 3 and pile line 1, if you would like to calculate, then we have to have the standard formula which are given, like phi E will be equal to 1 by pi cos inverse of lambda minus 2 by lambda. Similarly, phi D is 1 by pi cos inverse of lambda minus 1 by lambda. So to make use of this formula, we have to calculate the lambda value. To get the lambda value, we need to have once again this formula 1 plus square root of 1 plus alpha square by 2. Alpha is B by D. D is the depth of cutoff and B is the total length of the horizontal floor. Okay. So length of the horizontal floor from the figure is 53.5 in between the two cutoffs divided by D, the depth of this end sheet pile, the depth of this end sheet pile. So you have 103.5 on the top of the floor and bottom is 95. So 103.5 minus 95.0 is 8.5 is the total depth of cutoff. Initially, we assume that the thickness is negligible. Thickness of the floor is negligible. This is what one of the assumptions. And after arriving at the pressures at the key points, we apply the correction for the thickness. We apply the correction for the floor thickness. We apply the correction for the slope. Also, we apply the correction for the mutual interference of the piles. So these are the three corrections required to be applied. So whenever I say 103.5, it is the top of the floor that we are considering. But actually, the junction point is not at the top of the floor. It is at the bottom of this floor. But based on the assumption of negligible floor thickness, we will be calculating the junction pressures, making use of the Khosla's formula. So the depth of cutoff, the depth of pile is 103.5 minus 95.0, 8.5. So alpha will be equal to B by D, 53.5 divided by 8.5, 6.29. So making use of that, you can calculate the value of lambda. Lambda is 1 plus square root of 1 plus alpha square by 2. Alpha is 6.29. Substitute here. Wrongly it is written as 6.75, 6.29 here. Then you are getting 3.686 is the value of lambda. Once you know the value of lambda, I'm substituting here, you will be getting the junction pressure, the pressure at the key point E. This is point 3, the suffix 3 here because this is the pile line 1, this is the pile 2, and this is pile 3. So we have got the suffix E here, 3 here. Phi E3 is given by 1 by pi cos inverse of lambda minus 2 by lambda. 1 by pi cos inverse of lambda is 3.686 minus 2, 1.686 divided by the value of lambda 3.686. So substituting that 1 by pi cos inverse of 0.437 or 0.356 or 34.6 is the uplift pressure in terms of the percentage at the pile line 3 junction point E. Pile line 3 junction point E. Similarly, D3, phi D3. So the pressure at this point for the end pile at this point D. So phi D3 will be equal to 1 by pi cos inverse of lambda minus 1 by lambda. You just ignore because this is not appearing to be SR3 in clear. So I written again as phi D3. So 1 by pi cos inverse of lambda minus 1 by lambda. Lambda we know 3.686. So substituting that here, you will be getting 24.24 or 24% is the pressure at the junction point D3. Okay. To get phi C1, 100 minus phi E. So 100 minus phi E3 here in this case, 100 minus 35.6, so 64. Similarly, at phi D1, 100 minus phi D, so 100 minus 24, 76. You got now the pressures at the end sheet pile and the sheet pile at the beginning also. This is the pile line 1. So for pile line 1 also, phi C1 would be equal to 100 minus phi E3 and phi D1 will be equal to 100 minus phi D3. So you got the percentage pressures like 35.6% and 24% get the end sheet pile at the junction points of E and D. Similarly, at the beginning of the pile, so that is pile 76% for the points of C and D, for the point C and D. So you have taken the pipeline 3, pipeline 1, end sheet piles you have taken. End sheet piles we have taken. Okay. Now, pipeline 2 is the intermediate pile. So for this intermediate pile, this is the intermediate pile. So this is located at a distance of 16 meters from the first sheet pile, 0.5 meters from the beginning of this. So B1 starting from the beginning, so it will be B1 by D, 16.5 by D is the depth 8.0, which is equal to 2.065 alpha 1. L1 is square root of 1 plus alpha 1 square, and L2 is square root of 1 plus alpha 2 square, and substituting those things, you got the values of alpha 1 and alpha, L1 and L2. Once you know the values of L1 and L2, lambda 1 will be equal to L1 minus L2 by 2. L1 minus L2 by 2. You got here a negative value because L1 is less. L1 is only 2.2 and L2 is 4.7. So L1 minus L2 by 2 is minus 1.2155. Lambda would be equal to L1 plus L2 by 2. This is lambda 1. This is lambda. So this is 3.5075. Once you get the values of lambda 1 and lambda, substituting that, the pressure at junction point E, phi E will be 1 by pi, cos inverse of lambda 1 minus 1 by lambda. Substituting that, you are getting 71.8% is the pressure at junction point 2. Similarly, phi C is 1 lambda plus 1 by lambda, 1 by pi cos inverse lambda 1 plus 1 by lambda. So substituting that value, you will be getting 52% is the pressure at the junction point. So phi D at the bottom of the intermediate pile, 1 by pi cos inverse of lambda 1 by lambda. Just I would like to explain you the locations of E, C and D again. So this is a D, phi D, and this is phi C, and this is phi E. What is this? So this is the intermediate pile that we have. So for this intermediate pile, just like the locations, so for this is the end pile. Similarly, in the same fashion, you have the intermediate pile also. The locations are E, C and D. D is the bottom of the pile. C, the junction point inner side. E, the junction point outer side. But when you are taking the middle pile line 2, the respective values will be E2, C2 and D2. So you need to calculate the values of E2, phi E2, the pressure at point E2, phi E2. Similarly, the pressure at point C2, phi C2, and then the pressure at D, phi D2 have been calculated by making use of the formula. Just repeat the formula again. 1 by pi cos inverse of lambda minus 1 by lambda for phi E. Similarly, 1 by pi cos inverse of lambda 1 plus 1 by lambda for phi C. And then for phi D, 1 by cos inverse of lambda 1 by lambda. So taking all the three, you will be able to calculate the pressures at the junction points also for the intermediate pipe. So what you have done now, we have calculated the pressures. You have calculated the pressures for the end sheet piles as well as the intermediate pipe for all the junction points. Now these are to be corrected for three corrections. Number one, thickness of the floor, because while calculating by making use of the Khosla's formula, while calculating the pressures, it has been assumed that the floor thickness has been neglected. The floor thickness has been neglected. But in actual practice, thickness of the floor would be there. Let it be 1 meter, 1.5 meter, 2 meters thickness of the floor will be there, which cannot be neglected. Similarly, there is mutual interference of the piles, because we have taken each one as an independent variable, like method of independent variables, that what we have applied. So for the end sheet pile, when you are calculating, we presume that there are no other sheet piles available. Similarly, for the intermediate pile, there are no piles on the other both the sides. This is how we make the assumption. So the correction number 2 is for mutual interference of piles. Correction number 3 is for the slope corrections. So these are the three things, because while calculating the cost, while making use of the Khosla's formula, the assumptions are like horizontal floor, negligible thickness, and method of independent variables. These are the three things. For these three assumptions, we need to apply the corrections. So how to apply the correction for the thickness of the floor? You see here in this figure, for the thickness of the floor, how to apply the correction. We have been taking a horizontal floor of negligible thickness. If T1 is the thickness, if T1 is the thickness of the floor, we are assuming that the thickness is not there at all. That means we are taking the junction point at the top of the floor instead of taking the junction point at a depth C1, at a depth C, at a point C1, which is at a depth T1 below the top of the floor. So this is what the correction is. Please try to see here. Please try to see here. T1 is the thickness of the floor, and we are assuming that it is a horizontal floor of negligible thickness, which means that we are calculating the pressure only at the top of the floor, but we have to calculate the pressure at the point C1, which is at a depth T1, the thickness of the floor below the top. This is one correction that we need to apply. Similarly, for the intermediate pile also, if you see, this is the intermediate pile. We are taking the junction points at the top of the floor, like E, C. We are taking at the top of the floor E and C, but the actual junction points are E1 and C1. So, and maybe a thickness of T, intermediate floor with a thickness of T. And at the end of the piles, if the thickness is T2, EC are the junction points which are to be replaced by E1 and C1, and the total D2 is the depth of the cutoff. D1 is the depth of the cutoff here. D is the depth of the cutoff of the intermediate pile. So making use of this and making use of the appropriate correction formulae, we have to calculate the correction for floor thickness. Correction for floor thickness. So for example, at the junction point C, it is something like 5D minus 5C by D1 into T1, which is a AT value, which you already seen in the previous class. 5D minus 5C divided by D1 into T1. What is D1 and T1? T1 is the thickness of the horizontal floor, which we have neglected in the earlier case. And D1 is the pile thickness starting from the top of the floor. Starting from the top of the floor, the pile thickness. So 5D minus 5C by D1 into T1 is the correction for 5C1. So correction for 5C1 will be 5D1 minus 5C1 divided by D1 into T1. We already computed the values of 5D1 and 5C1 as 76 and 64.4 in terms of the percentages. Divided by 8 into 1.0 gives you 1.45 to be added. So correction for the thickness on 5C1. So 5C1 will be equal to the original pressure, the actual pressure, which is calculated by assuming the horizontal flow, plus 1.45. Okay. Then correction for at the junction point E1. This is at the junction point C. At the junction point E, 5E minus 5D by D into T. It is a subtractive value. So at the junction point 2, intermediate pile line, 5U2 will be 5E2 minus 5D2 divided by D2 into T2. D2 into T2, the thicknesses. So making use of this, you will be getting 1.3125 is a subtractive value. So in the same fashion, at 5E2, this is for 5E1, and similarly for 5E3 also, you need to calculate 5E3 minus 5D3 divided by D3 into T3. So if substitute those values, T is the thickness, D is the total depth of the cutoff starting from the top of the floor. Starting from top of the floor. So how are you getting this 35.624, etc.? These are the values of the pressures which are calculated based on the assumptions. So substituting those values, you are getting the correction for the thickness of the floor. Next is correction for the mutual interference of the pipe. You have seen the pile lines, pile line 1, pile line 2, and pile line 3 are there. If you just take pile line 1, pile line 2 will have an interference from, pile line 1 will have an interference from pile line 2. Similarly, pile line 3 also will have interference from the intermediate pile 2. Whereas the intermediate pile 2 will have the influence of 1 as well as 3 because it is at the middle. So correction for the interference of the pile on pile 1 due to pile 2, 19 into square root of d by b dash into small d plus capital D divided by b. So substituting those values, you will be getting the correction for the pile on pile 1 due to pile 2. Pile 1 due to pile 2. Similarly, correction for the pile interference on pile 2 due to pile 1, the reverse. It is pile 1 to 2 and 2 on 1. You have 3.258, a negative value will be the same thing with a negative value. So correction for pile interference on pile 2 due to pile 3 and then pile 3 to pile 3 onto pile 2. Then the slope correction will be like upstream slope. Upslope is given like 105.00 and 104 here. So 1 by 4 is the slope. So correction for the slope from the table for a slope of 1 by 4, it is 3.3%. So actual correction will be 3.3 into 4 by 37. So 37 is the total length. So this correction is applicable like 5C2 will be equal to 0.357 negative. So you got all the corrected pressures at the junction points of D1, C1, E1, D2, C2, E2, and D3, C3, E3. Some of the things which are directly exposed outside, we don't need to calculate. So for all other things, whether it is additive or subtractive, the pressures have been calculated. So this is the corrected pressures. Then the exit gradient has to be calculated. We know very well the exit gradient is given by the formula h by d into 1 by pi root lambda. H by d into 1 by pi root lambda. So you need to calculate the values of h, d and lambda. What is lambda? Lambda is 1 plus square root of 1 plus alpha square by 2. Alpha is b by d. Alpha is b by d. So substituting that, you are getting the value of lambda. Once you get the value of lambda, h and d are to be known. D is the depth of the pile or depth of cutoff. 103.5 the top of the line and 95 at the bottom. So 8.5 is at the exit at the downstream pile. That cutoff depth is 8.5. Similarly, the CPG head is 108.5 up to which the water is stored, crust level, top level. Minus 103.5 is the floor level. So head causing flow is 5. 5, 1.5, 5, 8.5 and 3.716 are the values to be substituted here. So that you will be getting the exit gradient 1 by 10, whereas the permeability exit gradient is 1 by 6. Hence, the weir is safe. The weir is safe. Same type of problem here, but instead of using the formula, we may need to take the values from the curves. There is no difference. Only thing is you have to make use of the curves. And just try to let you know how this curve can be used for getting the percentage pressures at the junction points of E, C and D. E, C and D. So this is the weir given. Okay, the thickness of the weir also is varying like 2, 1.5, and then here it is 1, and so on. The top level is 14.00. The bottom level is 12.50. So head causing flow is 14 minus 12.5, 1.5, and 2:1 and 3:1 this side. The slopes. Okay, there is pile line 1 and pile line 3 end piles, and you have pile line 2 also, intermediate pile also has been provided. D1, the depth of cutoff for the first pile line. D2, the depth of cutoff. Of course, D3, the depth of cutoff at the other side. So you have to calculate from the graph. So you need to understand about the graph, how to read the graph and how to get the values. It is so simple. You don't need to even remember the formula in this case, but you need to understand how to make use of this curve. I'd like to explain to you one curve for one value. The many things just by looking at the curves you will be able to understand. Uplift pressure in percentage at the junction points, at key points. So percentage of pressure at the key points of D1 and C1 for the upstream pile. So calculate, instead of alpha, you are calculating 1 by alpha. So D1 by B, 4 by 40.1. So you have the value of 1 by alpha, 0.1. So corresponding to 0.1, what is the pressure for D1? What is the pressure for C1? That means phi D1 and phi C1 are to be computed. We have 1 by alpha is 0.1. 1 by alpha is 0.1. So look at this Khosla's curve. So values of 1 by alpha, T by B, are taken on x-axis, and the scale for the percentage pressure P by H into 100 is given. The value of phi is given on y-axis. You have different cases like upstream end pile, downstream end piles, downstream pile, and then depressed floor. For all the things, the same curve can be used. In this problem, you have got the value of 1 by alpha to be equal to 0.1. Corresponding to 1 by alpha 0.1, what is the value of phi D? What is the value of phi E? You need to calculate. So if you see the horizontal axis, x-axis, 1 by alpha D by B is starting from 0.0, 0.2, 0.4, 0.6, 0.8 up to 1.0. In our problem, 1 by alpha is 0.1. So corresponding to 0.1, somewhere here, 0, there is 0.2. In between these two, it is a linear graph. It's not even logarithmic graph also. It is only linear scale. 0, 0.2, 0.4, 0.6, 0.8, 1.0. It is not logarithmic scale. It is only a linear scale. In between 0 to 0.2, identify the location 0.1. Identify the location 0.1, exactly midway between 0 to 0.2. Now, draw a vertical line to cut the phi D curve. This is the vertical line which is cutting the phi D curve. Draw a horizontal line to cut it. Is coming to 20. Phi D is coming to 20. I'll just show you again. in this figure. This is 0, 0.2. Since it is a linear scale, 0.1 may be somewhere here. For this 0.1, at this alpha is equal to 1 by alpha is equal to 0.1, just drop a vertical line. This vertical line is cutting the phi d curve at this point. At this point, if you draw a horizontal line, it is cutting, it is giving a value of a phi to be equal to 20. That means phi d you need to take 100 minus, right? So it is given here. Okay, so you will be able to get the phi d1 100 minus phi d, 100 minus phi d. So phi d1 would be equal to 100 minus phi d, 100 minus 20. What you get? 100 minus 80, 100 minus 20, 80%. Similarly, phi c also same curve. So this is the phi e curve. So for 0.1, if you drop a vertical line, it is cutting somewhere here, and the corresponding value is coming to about 29 or 28, 29, somewhere here, 27 or 28 or 29. So from the graph, it is coming to about 28.5. So 100 minus 28.5, 72.5% is phi 7. So you got the values of phi d1, phi c1. Phi e1 anyway will not be there because it's outside junction point. Then correction for the floor thickness, phi c1 will be equal to phi d1 minus phi c1 by d1 into t. So substituting these values, you got additive correction. So phi c1, once again, the thickness of the floor 19 into square root of so and so. So interference, for the interference of the pipe. So once you know the value of the pressures followed by the corrections, you will be able to calculate the corrected value of phi c1 72.5 plus 1.875 plus 3.08 is the total pressure at point C1. Similarly, phi d2 will be 80%. Similarly, for the intermediate pile also same thing. Make use of the curve and calculate the values of E2, D2, C2 and apply the corrections and compute the pressures. So this is how you need to make use of the Khosla's curves. These are very useful curves as compared to the simple equations. These are very useful curves because they are readily available and you'll be able to get the values from the graph directly. However, same thing can be obtained if you are making use of the formula and calculating also. There would be no difference. Only thing is all equations have been presented in the form of the curves here, and these are called the Khosla's curves. So in this lecture, I attempted for giving you a clear understanding of how to work out a problem on application of the Khosla's theory. So Khosla's theory, last class we have seen. Before that, we have verified the Bligh's theory and Lane's weighted theory. We identified what are the limitations of the Bligh's creep theory. Khosla tried to give a good explanation for all the limitations that are there in the Bligh's creep theory, and hence Khosla's theory has been more and more effective in computing the junction pressures, particularly for the floors on permeable foundations. Okay, so this finishes the topic related to that. This is closing, and I would like to go for the discussion on Unit 1 assignment. A few minutes I would like to spend if all of you are ready. Just a moment. Please hold for a while. I'm trying to take out the assignment 1. Yeah, somebody may respond. Is the screen visible to you? Is my screen visible?
Yes, sir.
Yeah. Okay. So this is assignment 1 which I have given. I request all of you to please concentrate in preparing a good notes in the form of assignment. This will be highly useful to you because you are all now at home. No, it becomes very difficult for you to have a good interaction among your friends for learning. So a separate level of learning should happen amongst all of you. So this is possible only when you start working something on a book with a piece of paper and a pen. Okay. So that is the reason why I have given the assignments. I requested all of you to please complete this assignment 1, and next once again we will be discussing assignment 2 in the coming class. Now this is explain various types of surveys for reservoir planning. So we started with a simple definition of a reservoir and why this reservoir is required to be planned. Very simple, like when you want to have a reservoir means you need to have flow of water first. So this flow of water is possible only in river. So reservoirs can be constructed only in river by constructing the dam across a river. So what type of surveys are to be carried out to plan for such type of a reservoir? Certain investigations are to be carried out for reservoir to be planned on a river. Okay, so hydrological investigations, hydrological surveys, geological surveys, etc. Next, enumerate different types of reservoirs and what do you understand by multiple reservoirs. Different classifications we have given in our notes also. And what do you understand by multi-purpose reservoir? Reservoirs, one type of classification is like a single purpose reservoir. The second is multi-purpose reservoir. Single purpose reservoir is meeting only one requirement, maybe domestic water supply to a town. That is a single purpose. Multiple purpose is, multi-purpose is something like domestic water supply to a particular town, and along the length of the canal, the canal may be meeting the water requirement for irrigation. Then it becomes multi-purpose. Next, mass curve of inflow, mass curve of demand. Then explain the procedure involved in the determination of the reservoir capacity for a specific yield. Draw with a neat sketch various storage zones of a dam reservoir and explain the procedure involved in the determination of the safe yield from a reservoir of given capacity. So we have shown for all these 4-5 questions from question number 3 to question number 6 completely on mass curve. So starting from the mass curve, how the cumulative flow will be taken with the time on x-axis, how the mass curve of inflow will be drawn, then mass curve of demand. So the slope of the mass curve of the demand will be usually constant. So when you are trying to make use of a graphical method, mass curve of demand and identification of the slope when it is drawn for the same scale, that is very, very important. Then you will be getting the peak points. At the peak points of the mass curve of inflow, draw a line. So you will be getting a vertical intercept. Maximum of all these vertical intercept will be giving you the capacity of the reservoir. Okay, various zones of storage also we discussed, like whenever a dam is constructed, there will be a dead storage, so up to which that is the minimum water level that is required to be maintained. Then full reservoir level, useful storage will be there, gross storage will be there, corresponding to the levels. Then trap efficiency and what are the various factors influencing the trap efficiency. This is an inevitable phenomena whenever a dam is constructed and the reservoir is formed. Definitely there will be siltation, sedimentation that takes place. So what is this trap efficiency and how what are the various factors? Once you know what are the various factors that are influencing the trap efficiency, you will be able to control the silt sediment into the reservoir, based on which you will be able to arrive at the life of the reservoir also. Usually the life of the reservoir will be like 20% of the total capacity is completely, 80% of the capacity is completely filled with the sedimentation. We say that the life of the reservoir is over. Okay, brief classification of dams. So we define the dam and what are the types of dams, merits, demerits of various types of dams. You have seen several types of dams. Each dam has got its own merit. Each dam has got its own demerit also. So choosing a specific type of a dam probably involves a wider spectrum of study. What are the various factors that are governing there? All the things are required to be taken up. For example, you need to have a dam on a permanent basis, or you need to have a dam on a very temporary basis. Accordingly, the type of the dam also changes. Explain the factors governing the selection of type of dam, which type of dam, where to construct, etc. will be. And if you have limited resources, if you have huge resources, if you want the strength of the dam, or if you want the dam to be constructed to a very height. So these are all the parameters based on which the selection of type of the dam depends, including the labor, like skilled labor are available or not, etc. So this is the problem where you need to draw a mass curve, then find the average yield from the catchment. Also, you need to calculate the live storage capacity and what is the, if 20% is the dead storage, what is the total gross storage capacity? Simple mass flow curve. Then another problem is a proposed reservoir has a capacity of 500 hectare meters, catchment area is 125 square kilometers, annual stream in flow average is 12 centimeters of runoff. You need to arrive at the life of the reservoir. Okay, so the capacity inflow ratio versus the trap efficiency table is given. So fitting to this, you have to arrive at the life of the reservoir. Next, this one also is once again the trap efficiency versus capacity inflow ratio is given, and you need to calculate the life of the reservoir. Okay, so these are the problems. Two problems on life of reservoir, and one problem on the inflows. Okay, I mean mass curve is given, and all other things are like procedure, theory, then definitions, then classifications, then factors that are governing for the selection and so on. So this is how the unit 1 has been demarcated. So I request all of you, you make a thorough study about this unit 1. And once you are ready with all the assignment answers for these assignment questions, I'm sure you will be ready with the unit 1 preparation. Followed? So this is why I have seen to it that all the topics are covered in this assignment. No topic is left, including the definitions, including the procedure, including the problems we have given all. Okay, so I request all of you, and I hope all of you must have completed the assignment 1. I'll post the assignment 2 also. If I already posted, you start doing it. Otherwise, I'll post again the assignment 2. In the next class, we discuss about the assignment 2, followed by a small topic related to our diversion headworks. Okay, thank you very much.